Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nur Shazli binti Zulkifli. I am a student of Electrical Engineering from University Tun Hussein of Malaysia, and today I would like to present about my project entitled Semi-Automated Strabismus Detection System, or we can call it as SAStraDS. And this is my group member, Dr. Ain binti Nazari and Dr. Rohida binti Ma'akil. Okay, so what is strabismus? It is an eye condition that does not look at the same direction due to the misalignment of the eyes. It is one of the most common vision disorder in children. It can bring a discomfort and serious negative impact on daily life. A timely diagnosis is needed to prevent it from getting worse. And why this is happen? It is because the nerve that transmits the information to the eye muscle most likely to have a problem. As we can see here, one of the eye is deviated from seeing the object in front of them, and the information sent back to the brain is most likely a double vision image. This is the example of double vision image. And also there are 4 types of strabismus, which are the esotropia, exotropia, hypertropia and hypotropia. And strabismus can occur due to the muscle dysfunction, farsightedness, problems in the brain, trauma or infections, and it can also be likely caused by the family history of the condition, and if they have a medical condition such as the Down syndrome or cerebral palsy. Okay, so for the problem statement, why we choose to do this project is because the detection of strabismus at early age is required before the visual pathway from the eyes to the brain are fully formed. The doctor can provide some easy treatment such as by providing the eyeglasses or prism lenses, or they can undergo the vision therapy. And if it can be treated with this solution, the patient, the individual has to undergo the eye muscle surgery to correct the strabismus eye. Next, most of the previous research only focusing on detecting either the patient has strabismus or not, and it lacks on the information of the misalignment measurement. And lastly, it is usually done manually at the clinic, and it requires expertise and time to get the results of the diagnosis. And also, rise in vision problem is expected to foster growth of the global spot vision screener market over the time frame of analysis from 2019 to 2029. Therefore, we create this system to act as pre-screening tool to help one of the vision problem, which is the strabismus. So this is the methodology. This is the framework of the detection for the system. It consists of 3 stages: pre-processing, feature extraction and classification. Okay, next is image acquisition. So this is the input image for the system, and for normal image we have selected 2 datasets, the CAVE and Siblings DB, and for the strabismus image we select iDisease dataset and Google Images. So the sample images will be taken from these 4 sources. And for the first stage, for the methodology, the pre-processing stage, firstly the input image will be fed into the system, and then we apply the Weiler-Jones algorithm to detect the eye area, and then we extract the red channel from the grayscale image. Next, we apply the contrast adjustment, consists of 2 methods, the contrast enhancement method and the unsharp masking. Lastly, for the pre-processing, we apply the medium filtering to remove the noises. The next stage is the feature extraction stage. To extract the location of the iris, we use the binarization method, and then to remove the noise, as in this system we focus on detecting the center of the iris, so we need to remove other noises such as the eyelashes, which they can affect the results of the center of the iris. And we apply the morphological operation to remove the noise. So we use 3 functions from the morphological operation: the dilation, region filling and opening operation. And this is the result image after the morphological operation has been applied. Okay, next, after the iris has been extracted, we use the regional descriptor to locate the coordinates of the iris. The regional descriptor will detect the center of the iris and it will give the coordinates of the iris. And so this is the results of the coordinates for left eye and the right eye. And for the misalignment measurement, we use the line ROI to get the information, and the user need to manually create the line ROI from the center of the iris to the inner corner of the eyes to get the information of the miselement measurement. So for the classification, we conduct by using the CNN with a pre-trained network of Google Net to determine whether the individual has strabismus or not. Okay, so this is the result of GUI for the strabismus detection system for normal individual and strabismus individual. Okay, so for the result, to see the effectiveness of the system, we calculate the performance measure for the iris detection in terms of accuracy, sensitivity, specificity, and error. And based on the bar chart, we can see the result. It shows high average value in all aspects. The accuracy, sensitivity, specificity, it shows that the systems are pretty accurate in providing the data for the strabismus and also has minimal error. For the contribution to society, the system can act as pre-screening tools for strabismus and can aid in recording the data during the treatment of the strabismus, and it is also suitable to be used in health campaign to get the data and to be stored and easy to handle without the expertise. Okay, so this is the GUI system where the user needs to click the push button and it will display all the information needed. So for the coordinates, the user need to select the result folder to save the image, and to get the coordinates, the user need to manually click the red dot, and for the distance, the user need to manually create the line ROI from the center of the iris to the inner corner of the eye to get the miselement measurement, and then the system will classify whether the individual has strabismus or not. Okay, so this is the research paper publication for this project, tracing of strabismus detection using half transform, range detection of strabismus based on the distance and coordinates of the iris, and strabismus pre-screening system with coordinates and distance of the iris. And if you have any question regarding this project, you can contact us at the information that we have provided. And that's all for my presentation. Thank you.